Hello students, Mr. Garcia here. Welcome back to another video lesson for Algebra 2. Okay, we're still working on reviewing Algebra 1 to make sure that when we get into more difficult topics, you'll be able to work through the assignments and also understand the concepts. Okay, so I'm going to ask you to pause the video for now. Go ahead and copy these two problems. Just copy them for now, and then I'll explain what you're going to do to work out those two problems. Okay, and once you're done copying, you can go ahead and press play. All right, now that you have paused the video and copied the problems, you're ready to continue. Okay, so on problem number 1, we're being asked to find a perimeter and the area of the rectangle. And notice that I divided here. Okay, P is for perimeter, and this is a formula for perimeter, and this is one for the area for, the formula for the area of rectangles. So what I see here is that I'm given that the length is this, x squared minus 2, and the width is 2x plus 1. Okay, to find the perimeter of a rectangle, we just substitute these expressions into that formula. So the perimeter is going to equal 2 times the length. The length is x squared minus 2 plus 2 times the width, and that's 2x plus 1. Okay, now I'm going to distribute. Okay, so 2 times x squared is going to be 2x squared. 2 times negative 2 is going to be negative 4, plus 2 times 2 is going to be 4. So that's going to be 2 times 2x is 4x. 2 times 1, 2 times 1 is 2. Okay, and now I'm going to simplify this. So I'm going to combine like terms. So in the end, the perimeter is going to be, I don't have any other x squared, so this one is going to be by itself. So 2x squared, and then I only have a positive 4x, so plus 4x, and then I have a negative 4 and a positive 2. So that leaves me with negative 2. So this is the perimeter that represents, this is what's going to represent the perimeter of this rectangle using algebraic expressions. Okay, now the next one, the area I just have to multiply the length times the width. So that's going to be x squared minus 2 times 2x plus 1. Now x squared times 2x, don't forget properties of exponents. Okay, so x, so this will be 2, and x to the second times x to the first. You add the exponents. Okay, so this is going to be 2x to the third, or 2x cubed. So that's this one here. And then x squared times 1 is going to be plus 1x squared, or just x squared, and then negative 2 times 2x, that's going to be negative 4x, and then negative 2 times positive 1 is going to be negative 2. And I can't combine this 2x cubes with anything else here, nor the x squared, nor the negative 4x, nor the negative 2. So that means this is going to be the area of that rectangle. Okay, I hope that makes sense. But let's move on to the next problem. Now this one here, you're given a bunch of problems, a bunch of words, and you're supposed to make sense out of those words and also understand some symbols. So this is saying find the area of the shaded region. So that's this area here that's shaded. Okay, so we don't know that area. And what I'm missing here that I forgot to add, this is 7x squared minus 2. Okay, so that's the total area. So the total area is 7x squared minus 2, and the non-shaded area is, let me just add, okay, it's x squared plus 5. So this is NS stands for non-shaded, so x squared plus 5, a sub t, that represents the total, t for total, so that's going to be the total area. So to find the shaded area, okay, which is this area here, what we need to do is we take the total area, which is this one here, and subtract the non-shaded area, which is this space here. So I'm just going to write that down. So the shaded area is going to be equal to the total area, which is 7x squared. And I'm going to use parentheses here, and you'll see why in a moment. Minus 2. And then since I'm subtracting, minus open parentheses again. Okay. And this is x squared plus 5. And now, don't forget, there's a negative 1 implied. So we need to distribute that negative 1. So negative 1, we'll do that in a moment. So I'm going to remove the parentheses. So this will be 7x squared minus 2. And now I'm distributing negative 1 times x squared is going to be negative x squared. Negative 1 times positive 5, that's going to be negative 5 or minus 5. And now I see that I have 7x squared and negative 1x. And when I combine those two, I'm left with 6x squared. And next is going to be negative 2 and a negative 5. Those two combined become a negative 7. So the shaded area is found or given by this expression here, 6x squared minus 7. And if you haven't copied this problem, go ahead and copy it now. So press pause, copy the problem, and then press play to continue. Okay, so on this one again, we have a word problem kind of, and we have some geometry and algebra combined. Okay, so this might be a challenge for some of you. So this says the measures of two sides of the triangle are given. So it's this side and this side. So we know those two sides. If P, the perimeter, is equal to 32x plus 15, find the algebraic expression that represents the third side. Now, this one we don't know, okay? But we know the perimeter. So the perimeter is the total when you add up all the three sides of the triangle. So we know the total, and we know two parts. So it's similar to the previous problem, but instead of area, now this is perimeter. So what I'm going to do is I'm going to say, I'm gonna set up not an equation, but an expression that says this minus this is going to be the length of the third side. Okay, so let's see if you can follow me here. So the perimeter is 32x plus 15, and watch what I'm going to do. I'm going to use parentheses, and I hope you understand why. Okay, I'm subtracting. If you don't do this, you are going to get confused and end up with something that's incorrect. So I'm going to start with this one, minus 5x plus 2, okay, minus another parenthesis again, 12x minus 4. All right, so then I'm going to remove the parentheses, so this will be 32x plus 15. But now I'm going to distribute that negative 1 that's implied. And that's going to change everything that's inside of these two parentheses. So minus negative 1 times 5x. I don't know why I did that. Let me go back to purple. Okay, so minus 5x. Negative 1 times positive 2. Negative 2. And then minus, okay, because of that sign, minus. Negative 1 times 12. So that's going to be 12x. Negative 1 times negative 4 is going to be positive 4. And now I'm going to combine like terms. So I see that I have 32x, negative 5x, and negative 12x. So if I add negative 5x and negative 12x, they combine to negative 17x. But I have 32 positive, so 32 minus 17, that leaves me with 15x. Okay, now let's do the constants. So 15, positive 15, negative 2, positive 4. I'm going to combine the positives. 15 plus 4 is 19. 19 minus 2 is 17. So there is the length of the third side. So this will be 15x, and this should be plus, right? Plus 17. So this will be the answer to that problem. Okay, last three problems. These have to do with graph, and I know you watched the video on Monday, okay, and you also got the handout that had some problems that we needed to graph. Okay, so if you remember, this has to be in slope-intercept form. We cannot graph this, okay? It has to be in this form. So it has to be in this form first. So y equals mx plus b, where m is the slope and b is, yep, you got it, the y-intercept. Okay, so I'm going to isolate the 3 y's. I'm going to add the 4 x's, so plus 4x. So then I have negative 3y equals positive 4x minus 9. Okay, next I'm going to divide, because I want the y by itself. I'm going to divide by that negative 3 on all 3 terms. So then that gives me the y by itself. Okay, but this is this becomes 4/3, and it's going to be negative. Okay, so that's the slope. And negative 9 divided by negative 3, that's going to be positive 3. So this is the equation of the line. Now, we're not done because this is saying graph. Okay, so what I'm going to do is I'm going to get a piece of graph paper here, and I'm going to start with the y-intercept. The y-intercept is 3, so then this is right here. This is where the line will cross the y-axis. Okay, and the slope is negative, so that means the line will be coming down from left to right. So if I go up, then I have to go to the left. So a rise of 4, 1, 2, 3, 4, and a run of 3. 1, 2, and 3. And if I go down, don't forget you need to get plot at least 3 points to graph lines for this class. So if I go down 1, 2, 3, 4, I run 1, 2, 3 to the right. Okay. Now I'm going to get my ruler or a straight edge to help me sketch the line. So then I connect the points, and this is the line that represents the equation that we're given here. Okay, so there is number 4. Let's go on to number 5. Number 5, we need to graph the line x equals negative 5. That means the slope is undefined. So this is just a vertical line, and I'm looking at where x is equal to negative 5. So then I have my graph here. X is equal to negative 5 here. So negative 1, 2, 3, 4, and 5. I'm going to plot a few points, and then I'm going to connect them. Okay. So remember I said it's undefined. If it's a vertical line, then that means the slope is undefined. Y can take on any value, but x will always be negative 5. All right. So there's number 5. Last one. Number 6, graph the line y equals negative 4. So again, I have my graph here, and I'm going to look for the y-intercept, which is where the line crosses the y-axis. The slope of this one is 0, so that means we will have a horizontal line. So y is equal to negative 4, 1, 2, 3, 4. I'm going to plot a few points, and then I'm going to connect them, and that will show me the line of the equation y equals negative 4. And for this one, for any value of x, okay, y will always be negative 4. So just to tease your brain here, what will be the range of this graph? Okay, also, what will be the domain? I just want you to think about that, because we're going to run into this next week. All right, that's all for now. See you soon. Bye-bye.